I hope all of you are doing well. My name is Shriya Bansal and I'm currently working as a software engineer at Microsoft, and I'm also an educator at Relevel. So now in the first video, having already talked about what exactly is a thread and what is the difference between a thread and a process and a program, we're now going to move ahead and talk about two things. One is what is a single threaded process and one is a multi-threaded process. Okay, so the definition is very simple and you can see the diagram itself to understand it the best way possible. Whenever we talk about a single threaded process, for the entire process you just have a single thread for it. So that single thread contains all the steps of the execution, and based on that it executes the process and all the tasks present in the process. But whenever we talk about a multi-threaded process, in a multi-threaded process, as the name suggests, for a single process, we have different threads. And all the threads, like we know, have their own registers, have their own stack, but the memory that they use is common. So because of having multiple threads or a multi-threaded process, we basically have multiple threads which basically execute parallelly and basically, I would say, speed up the execution of a process. Whereas if you're using a single thread, that single thread only contains all the steps of the execution, and I would say implement them in a sequential manner. Okay. Now this is what a similar difference or a simple difference between both of them would be. Next, what we would do is we will kind of concretize all the points between the difference between a process and a thread and just take a quick recap about it. So a process simply means any program which is currently executed. Whereas when we talk about thread, thread simply means a segment or a part of a process. It's not the entire process. Thread basically takes care of a particular task or a particular segment of a process. Next, what we have is the idea that the process consumes more resources, whereas compared to a thread consumes fewer resources and comparatively they are faster as well. That is why the process require more, or another point is that to create a process, it takes more time, but comparatively the process to create a thread is comparatively faster and it takes less time compared to a process. Process is nothing but a heavyweight task, okay, whereas thread is a lightweight process, okay, because thread is basically taking a process, dividing its task into lightweight processes and then executing it. The process takes more time to terminate, whereas similarly, the thread takes less time for creation also, and it takes less time for termination as well. Next, what we have is that processes have independent data and code segment. Each and every process will have a separate memory, separate data, and separate code segment. Whereas a thread, for a particular process, there can be multiple threads, and all the threads basically share the data segment, the memory, the code segment files with their peer threads. Okay. Whenever we talk about process, it takes a lot of time to do context switching between process. Why? Because all of them have their different memory areas. Whereas for thread, it takes less time for context switching because they are sharing the memory which is available between their peer threads. Next is that the communication between processes needs more time compared to a thread, obviously because they have different memory areas. Whereas inter-process or inter-thread communication basically needs less time. And the last point being that if for some reason, if a process gets blocked, then the remaining processes can continue their execution. For example, there is a process and due to something, the interrupt happens and the process is getting blocked. But the other processes do not get blocked because of that process. They can still continue their execution. But whenever we talk about a thread, okay, if a thread gets blocked, all of its peer thread also gets blocked. Okay, and this user level thing we're just going to take a look at very quickly. Okay, but this kind of, in a very good diagrammatical and differential representation, shows you a difference between a process and a thread. Many people do get confused between two, but you do not have to get confused. With these simple points kept in mind, you should be able to execute and work on threads very easily. Okay. So the next part that we will talk about now will be what are the advantages of using a thread, right? Why do we really need threads? What's the need and what advantages do thread provides? First would be responsiveness, that threads are far more quick and far more responsive compared to a process. Second is resource sharing. Since they are sharing the resource, it's far better utilization of resources compared to process where every process has their different memory area and resources. Economy, that is, it is more economical to create and manage threads because it is easier to work with them compared to processes. Scalability, one thread runs on one CPU. In a multi-threaded process, threads can actually be distributed over a series of processors to scale as well. So in terms of scalability also, multi-threaded processes are far easier to scale. Then the context switching. We have already talked about it so much and I would like to repeat it once again, that since threaded peer threads basically have common area of memory, it is easier to do context switching. It's very smooth and the overhead is very low. Okay. Next is the enhanced throughput. Using threads, your overall throughput of the system increases. Let's take an example for this. Let's say a process is divided into multiple threads and the function of each thread is basically a job. So a big process, a big task divided into threads, every thread doing some particular task and every task is considered as a job. Now the number of jobs, since now if you execute one process over a period of time, so in 10 seconds, let's say you complete one process, but if that process gets divided into 5 parts, right? So each of them is taking care of a particular part and all of them are completing parallelly. So that will mean that the number of jobs completed per unit time will increase and hence the overall throughput of the system will increase as well. Okay, and that's what is the overall advantages if you are using threads. Okay, perfect. Now let's move to the next part and talk about the different types of threads which are present. Okay, so we basically have two types of thread. We have a user thread and we have a kernel thread. Okay, now let's take a detailed description about what these user threads and kernel threads are, and then we'll take a good differentiation between them. So whenever we talk about user threads are above the kernel and they work without kernel support. Okay, just to give you a little bit more idea. So the operating system does not recognize the user level thread. Okay, so how does it work is something like this. Let's take a look. I'll show you through a diagrammatical representation so that you can fully understand this. So when we have our system, okay, so there are two types of threads. There are user level threads and there are kernel level threads. So this is the user space. Okay, here, let's say for process P1, for process P2, you have created multiple threads. And this is the user space. Okay, this is the kernel space. The user space is associated and not bothered about the kernel. Okay, and before that you also have CPU over here. Okay, so what happens is your operating system, okay, does not recognize, or your user level threads are not recognized by the kernel. Okay, the operating system does not recognize the user level thread. User level threads can easily be implemented and it is actually implemented by the user. Okay, if a user basically performs a operation, right, and if a user basically performs a blocking operation, the whole process is blocked. Okay, and the kernel level threads do not know anything about the user level thread. Okay, so the idea is that the thread management kernel, okay, there is a thread management kernel that is not aware of the existence of user level threads. The thread library, okay, basically contains code for creating and destroying threads, for passing message and data between threads. So what happens is entire every process now, there is a thread library, and the thread library for each process contains code for how to create a process, how to destroy a process, how to pass messages and data between threads, for scheduling the execution of the thread, and for saving and restoring the thread context, because we do context switching. Okay, now the application always starts with a single thread. Okay, and that is the user level thread over here. Okay, what are the advantages of using user level thread? It is faster, it is efficient. The context switch time is shorter than kernel level threads. Okay, and it is simple to create, switch, and synchronize threads without the intervention of, I would say, processes. Okay, whereas whenever we talk about kernel level threads, they are supported within the kernel of the operating system. All modern operating systems support kernel level threads, allowing the kernel to perform simultaneous tasks and or to service multiple kernel calls simultaneously. So the threads created by the user itself, right, for the execution of a process and for any task, that's a user level thread, right? But the kernel level thread are basically used to simultaneously perform multiple tasks, right, which are basically supported for the operating system. Okay, so the kernel level threads are recognized by the operating system, whereas the user level threads are not recognized by the operating system. Okay, there is a thread control block and a process control block in the system for each process and each thread. Okay, for every thread we have a thread control block, for every process we have a process control block. Okay, the kernel level thread is actually implemented by the operating system, whereas user level threads are created by the or implemented by the user. Okay, the kernel knows about all the threads and it manages all of them. Okay, the kernel level thread usually makes a system call to create and manage the threads from the user space, and the implementation of the kernel threads is a little difficult from the user thread. Okay, and also here the context switching time is also a little bit more. So you can also think of it like this, just that same diagram but with a slightly difference. This is the user space, this is the kernel space. Okay, and these are the kernel threads. And this is your process. These are user level thread. These are kernel level threads. Okay, so that is what the overall idea is. In kernel level threads, the thread management is done by the kernel, and there is no thread management code in the application area because it is handled by the operating system as well. They are directly supported by the operating system. Okay, any application can be programmed to be multi-threaded. All the threads within an application are supported within a single process. The kernel maintains the context information also for a process as a whole and for the individual threads of a process. Okay, scheduling by the kernel is basically done on a thread basis. Okay, the kernel takes care of the thread creation, scheduling, and management of the kernel space. Okay, but like I said, kernel threads are a little bit slow to create, and they are managed by the user threads. Okay, so you can take a look at the differences also over here. User level threads, these are implemented by the user. Kernel level threads are implemented by the operating system. User level threads are not recognized by the operating system. Kernel level threads are recognized by the operating system. User level threads, the context switch require no hardware support, but in case of kernel level threads, hardware support is needed. That's why context switching in kernel level threads is slower. In user level thread, they are mainly designed as dependent threads, okay, because they are dependent on the, like you can see from the kernel level threads, whereas kernel level threads are mainly designed as independent threads. In user level thread, if one user level thread performs a blocking operation, then the entire process is blocked. On the other hand, because kernel level threads are independent, if you perform a blocking operation, then the other thread can still continue the execution. What are the examples of user level thread? Java thread, POSIX thread, etc. Whereas the example of kernel level threads would be Windows Solaris. Implementation of user level thread is easy, right? Is done by the thread library only, like I talked about, and it is quite easy. While the implementation of the kernel level thread is done by the operating system, and it is a little bit complex. Okay, the thread is generic in nature and can run on any operating system, but kernel level threads are specific to the operating system. Okay, just to reiterate on the part where we talked about I would say the thread library, I'll just quickly rephrase that part as well. So for every process, okay, for every process, there is a thread library that contains code for creating and destroying threads, okay, for scheduling threads, okay, for scheduling thread execution, for passing message and data between threads, okay, and for storing and restoring the thread context, because we have to do context switching. Okay, these are all the things that the thread library basically takes care of. Okay, when we are talking about user level threads, some of the advantages to actually pinpoint all of them would be that in here, okay, in this process of thread switching, okay, we do not require the access or the privilege from the kernel. First of all. The second thing being over here, they can run on any operating system. Third would be that scheduling can be application specific. How do you want to do the scheduling? Not kernel specific. Okay, over here. Okay, and they are fast to create as well as to manage it. Okay. These are some of the advantages of basically, I would say, using user level thread. Okay, there are others also. For example, we do not require to do any modifications using the operating system. Okay, it is more efficient as well, right? And it is more easily implemented as well. Okay, but some of the disadvantage is that there is lack of coordination between the thread and the kernel. User level threads lack coordination between the thread and the kernel. Okay, and if some issue works, even if you have one blocking operation, right, here you can see that if one user level thread performs a blocking operation, the entire process will be blocked. Okay, so that is also a disadvantages of using kernel level user level threads. Okay, next we'll talk about, so I've discussed the second point as well, blocking operation. Next, we talk about kernel level threads. Some of the advantages of using kernel level thread would be that we can simultaneously schedule multiple threads from the same process. Okay. Another advantage is that if one process is blocked, kernel can schedule other thread. Okay, and the third one is that I would say, when we talk about the kernel level threads, right, the kernel level threads is the scheduler may decide to spend more CPU time in the process of threads being largely numerical. Okay, so ये भी एक importance होता है. And kernel level threads are fully aware of all the threads which exist. Whereas the disadvantage is that they are slower, it is difficult for the implementation as well, all the points which already came. Okay. So this concludes our discussion of talking about user level and kernel level threads. Okay. Just to quickly revisit what all we discussed, we started our discussion with talking about single threaded process and multi-threaded process. Then we took a good differentiation between a process and a thread. And after that, we took a few advantages, followed by the discussion of user threads and kernel threads. It is very important that you understand these topics. These are largely theoretical, so you don't have to go into a lot detail. But at the surface level, you should know all of these terminologies because they are going to be used a lot. Okay, perfect. Thank you so much for taking a look at this video. Then in the next video, we are going to talk about the multi-threading models. Okay, we are going to basically see how the user threads can be mapped to kernel threads and with what different strategies we can do that. Okay, so stay tuned for the next video on threads as well. Thank you.